Hello, today we'll be learning about transformations of functions. Now, what are transformations of functions? Well, here we go. We have this little thing over here, which is a function. And this is how you sort of write down it as. So kind of like a quadratic equation, sort of. And so, let's just shrink this. What does it mean by transformations of functions? Well, in this little thing here, we have all of these little letters, and it comprises of A, B, C, and D. Now, what do these letters mean? Well, let's get into that right now. So, if we're going to look at letter A, first of all, what does letter A mean? Well, let's just grab this giant thing. Let's just reverse that because we messed out a bit of stuff. There we go. This is what A means. So A, the letter A in this little equation, the transformation of a function. So all of these little letters, these variables, are a part of the transformations that transform the functions, and we will discuss them individually. So the letter A represents the dilation from x-axis. The letter A represents the dilation from the x-axis and it is also parallel, to the y-axis. Now, what does that mean? Well, I don't really quite understand the from x-axis, but what I understand is if we were to do just a parabola like that. So let's make a better one. Okay, well, doesn't need to be great. What it means by parallel is that this is the y-axis, right? And this is the x. This is y and this is x. So x goes across and y goes up and down. And so parallel means going the same way, kind of. You could think of it as well. So what it means by parallel is that it goes like that as well. So these are parallel of each other. Now, other words you may encounter are perpendicular. Now, perpendicular means it's like 90 degrees out of it. So 90 degrees out of this is like this way. So it's x-axis. Basically, parallel means up and down as well. So it's perfectly the same direction. And so, basically, what it's trying to tell us right now is this letter A dilates from the dilates by parallel to the y-axis, and so it means that it increases the y-axis. Increases the y-axis. Now, how does it increase the y-axis? Well, it multiplies with it, and that will also be the same with the dilation of B letter over here that we'll discuss later on. So A multiplies with the coordinates. So example, x and y. These are your normal coordinates, right? So your x coordinates and your y coordinates. Now what A does is, since it is parallel to the y-axis, it goes up and down with the y-axis. It basically multiplies with it to dilate it. So dilate is like to change, whether to make it like steeper or bigger, like short or bigger kind of way. But you'll understand as I go on with all these questions over here. So A is the dilation that is from x-axis and is parallel to the y-axis. So parallel goes with the y-axis. So what we do is we just get rid of this little comma actually. We just put the A here, and obviously this means A is multiplied with y. So now that we know that A is multiplied with y, so the dilation of A, well, when A dilates with from the x-axis and is parallel to the y-axis, all it does to the coordinates is multiply with the y-coordinate. It doesn't do anything with the x-coordinate, it just multiplies with the y-coordinate. So let's observe these three questions here, and these three different, well, 6 different points. And just observing from it, this is written as y equals af b x 6c plus d, and a, if we just write only a, it is represented by this. And f of x is just an example, but you could really write it out as ax, so which is just a times x. So this is sort of how you would write it down. So mainly you would write it down as y equals a of x, a f of x, and this is what is represented. So we can observe that 1 is multiplied with x because we observed that it's basically just a and x, and then multiplying. And so what numbers multiply with x in these questions? Well, we're going to observe that 9 is, 5 is, and 8 is. So that must be in all of these questions. So let's find, if the question was asking us to find what the dilation in these are, we would say that a is the dilation, remember. A is equal to 9, a is equal to 5, and a is equal to 8. That is the dilation from x-axis parallel to y-axis. That if they were to ask us what is the dilation. Now that we've sort of identified what a is, which is 9, 5, and 8, remember how we said a multiplies with the y coordinate? So here we have been given the coordinates, or the points. So let's do this first question here. Y is equal to 9x, and the points they give us are 3, 2, and 4, and 8. So remember how I said a multiplies with y? Well, this is y, and this is y. So basically it's just simple multiplication. So 2 times 9, which we've identified is a, 2 times a, and 8 times a, and that obviously becomes 2 times 9 and 8 times 9, because a is 9. So that means these coordinates change over to become 3 and 18, and 4 and 72. So these are the new coordinates now, after transforming them. So originally these coordinates were originated from this equation, y equals x. But since we started adding another variable, which is a, and we started dilating it from the x-axis, which is parallel to the y-axis, it has seen a change. So if we just write down a little... So basically that's how it works. That's how the dilation from x-axis parallel to y-axis work. It basically increases your y-axis. So if it was 3, 2 on a graph, 3, 2, well now it's still on the same x-axis, it's still on 3, but it's just, it went from 2 here to 18 here. So it's become, so by the time it's reached like here, it's become way steeper. So you can see that the graph has become steeper. It's increasing way faster, at a faster rate than before. So before, these coordinates were actually part of the old graph, which is y is equal to x. But since we added a variable of a, which is equal to 9, it has turned into y is equal to 9x, because we added a transformation, which is a. So let's just quickly do the rest. So it's just simple multiplication to the y coordinates. So let's do that. So we know that from this one, a is equal to 5 from here, and they've given us the coordinates of 4 and 8, and 3 and 9. So basically what you do is just times the a coordinate, multiply by 5, multiply by 5, and then the new equation from these coordinates are from y is equal to x. The new equation of y equal to 5 times x, which is the new transformation of 5, has resulted in coordinates being 4 and 40 and 3 and 45. So these are the new coordinates after the transformation of a is equal to 5. So transformations hugely impact the results of what your graph will look like. And let's do the last one, y is equal to 8x. So our original equation we're given is y equals x, and the coordinates that we're given are 2, 4, and 1 and 3. But then when it transformed by dilating it from x-axis and parallel to y-axis by 8, sorry, which turns it into 8x, we also have to times the y-axis by 8. So times by 8, times by 8, resulting in 2, 8, 16, 24, 32, and 1 and 16. Oh, sorry, not 1 16. Oopsies. Simple math error. Cringe. 24, sorry. So, basically, after transforming it by a dilation of 8, when it is parallel to the y-axis, it results in these new coordinates here that are way different from the original coordinates after transforming the function by a amount. So that's what a does. It basically just changes the y coordinate, and it will change the graph to become like more steeper, and we will show that later on. So b is the dilation of 1 over b from y-axis and parallel to the x-axis. Now, as we have learned that when a was parallel to the y-axis, it caused the coordinates, sorry, not the graph, the coordinates of x and y to be changed to x and then a times y. So if it's parallel to the x-axis this time, that means that the coordinates of x and y will now be changed into, guess what, bx and y, because since it affects the x-axis because it's parallel to it, that causes the x and y to change over to b of b times x, y. So remember how a was parallel to y-axis? That means that a was timesing a multiplied to y. Well, this time, since b is parallel to the x-axis, it is multiplying with x. Very simple, really. And so, the only confusing part about b is that it has to be put into a formula of 1 over b. So, let's do some questions at y is equal to 2x real quickly. So, y is equal to 2x, right? Well, b is actually not 2. Why? Because you have to put this into the equation. So we can identify that the only number here is 2, that's multiplying with x. And they kind of give us what b is, but not really at the same time. Because you have to utilize this equation of 1 over b. So you could identify this 2 as b, I guess you could say. But it isn't really what... But this isn't the actual value of b. This is just the result of b. So, the result of b, so we can say the result of b, so RB, the result of b is equal to 1 over b, right? So the result of b is 2, so we can write 2 in. And then we already have everything else, 1 over b. And we want to find the actual value of b, which is the dilation of 1 over b from y-axis to parallel to x-axis. And we don't know what b is, we only know the result of what b is. So let's do that. So to get rid of divide by b, we have to multiply b. So we can cancel that out. But you do on one side, you have to do on the other side, so you have to times b on this side as well. And that obviously results in 2b is equal to 1. Now we want to get rid of the 2, so we can have b on itself. So we divide by 2. So this is a multiply, so we divide by 2. Do on one side, you have to do on the other side, so you want to do 1 over 2. Because 1 divided by 2 is 1 over 2. Therefore, b is equal to 0.5 or 1 over 2. So that is actually what b is. B for y is equal to 2x. B is actually 1 over 2. B is not 2. 2 is just the result of b. But the actual value of b is found by inputting of RB, the result of b. So the result of b is 2 is equal to 1 over b, which is the equation they give us, or the formula. So let's quickly identify what b is for the next 3 questions here. So y is equal to 4x, right? we can identify this as RB, the result of B. So we remember our result of B is equal to 1 over B. That means 4 is equal to 1 over B. And then 4B is equal to 1. Therefore, B is equal to 1 over 4 after you balance that. So B is equal to 1 over 4 for y equals 4x. Let's do y is equal to x over 2. Now this is the same as just this whole equation here is the same as x x multiplying with 1 over 2, which is like that, which is just multiplying. You just multiply them, so x times 1 is equal to x, and 1 times 2 is equal to 2, resulting in x over 2. And so what happens now? Well, they already give us x is over 2, so we can identify the result of b is 1 over 2, because the 1 is just not there, but it is there. And yeah, so it's 1 over 2. The result of b is 1 over 2. So 1 over 2 is equal to 1 over b. Now, you could just cross multiply this, which is you just times these two. So 1 times b times 1 over is b, and 2 times 1, 2 times 1 equals 2. So b is equal to 2. So yeah, or if this confuses you too much about cross multiplication, we can just do it the normal way. 1 over 2 is equal to 1 over b, and 1 over 2b is equal to 1, and give me a bit more space. 1 over 2b, you divide by 1 over 2 to get rid of this, so b is equal to 1 over 1 divided by 1 over 2. And when you do, you can't divide a fraction, so you have to multiply it. And when you multiply it, you have to flip it. So you have to flip one equation, and since it was 1 over 2, you have to now flip it to 2 over 1, which results in same denominator. Well, they're just timing, and 1 times 1 is equal to 1. 1 times 2 on top is equal to 2, so b is equal to 2. That's another way you can do it. It's just a bit longer. So, but anyways, that basically just means that b is equal to 2, okay? For when y is equal to x over 2. So, when y is equal to x over 4, hopefully you've already realized the pattern. This is the result of b. RB equals 1 over b, and we know this is the result of b here. So, x over 4 is equal to 1 over b, and we know that x is just 1. I mean, we don't know what x is, but we know that next to x here is 1 over 4. So 1 over 4 is, because 1 over 4 is the result of b, sorry, is equal to 1 over b, you cross multiply, or whatever you want to do it that way. 1 times b is b, is equal to 4 times 1, which is 4, so 4 is equal to b, or b is equal to 4, it's the same way, I just ordered it differently, sorry. So yeah, b is equal to 4 for that equation, really simple. So let's start working on it. So you remember how I said that b affects x by multiplying with it, like what a did, but a did it with y? Basically it's the same thing. Basically b multiplies with x. So let's do this question. What will happen to these points 2 and 3 and 4 and 8 for the different b dilations? These are different b dilations. So let's do it. So y is equal to 2x. We identified that by 2 is the result of b is equal to 1 over b, and that means b is equal to 1 over 2. So b is equal to 1 over 2, and we want to say these are the coordinates, 2 over 2 and 3. That's a horrible 2. 2 over 3, right? Remember how I said b affects x, so b times x and then y. That's what b does, it multiplies with x. Well, that causes it to be 2 times 1/2, 3. Which is 2 times 1/2 is just half of 2, which is resulting in 1 and 3. So this is the new coordinate after the transformation of y is equal to 2x. Now these coordinates are originated from the original equation of y is equal to x. keep that in mind. Now, they don't need to always be. They can be like a parabola, and they could originate from y is equal to x squared, but we're not going to go into the deep understanding of everything. So let's go into y equals 4h. We identified that b is equal to 1 over 4. And so when we encounter 2 and 3, so let's just get rid of this. I don't want to do too many work today. 2 over 3, right? And 1 over 4, so it's just 2 times 1/4 and 3. So this is a bit hard for me to do. I know it's 0.5, but I'll show you how to do it. So it's the same as 2 over 1 times 1 over 4. So you just times everything. So 2 times 1 is 2. And 1 times 4 is 4, and that is equal to 1/2, which is 0 to 0.5. But basically, this turns, after the transformation of y is equal to 4x, where b is equal to 1 over 4, after putting it into the 1 over b formula over here, that causes the newly transformed coordinates or points to become 1 over 2 and 3. So these are new coordinates after transforming and dilating it with b. So let's do y is equal to x over 2. We identified that after putting 1 over 2 is equal to 1 over b, we found that b is equal to 2. Therefore, 2 and 3 are now multiplied, remember, where b times x, y. So, since x is equal to 2, and b is equal to 2, it's 2 times 2, and y is equal to 3. So the newly transformed coordinates are 4 and 3, instead of 2 and 3. And lastly, y is equal to x over 4. We identify that b is equal to 4 after putting into 1 over 4 is equal to 1 over b, and we found that by cross multiplying b is equal to 4. And so the coordinates 2 and 3 is 2 times b and 3, and b is 4, so 2 times 4, and oops, this is horribly messed up. 2 times 4 and 3 results in the newly transformed coordinates of 8 and 3 after you dilate them by b. So basically, in summary of a and b, these are the summaries. So summary. A multiplies with y. B multiplies with x. And this turns out to be written as this. X, y turns into, for a, the variable a, turns xy, normal coordinate, into xay. But b turns the normal xy coordinate into bx and y. So this is the summary for both the variables a and b, and I'll see you for the next part of this video, which we'll be discussing about c and d, which are way simpler to explain. So have a nice day, and I'll see you later. Keep in tune.